everyone, welcome to class 11 mathematics chapter 3 trigonometric functions. In our previous module, we learnt about what is trigonometry, what are its wider applications in various fields, what are angle measures, degree, radian and their relation with real numbers. In today's module, we shall cover relation between degree and radian, to convert between degree measure and radian measure, notational conventions and few more examples to clear the concept more. Now, relation between radian and degree measure. A circle subtends at the center an angle whose radian measure is 2 pi. If it is a unit circle, then we can say complete revolution corresponds to angle 2 pi. This is 2 pi, and if it is considered in degrees, a complete revolution by this terminal side is represented by 360 degree. So, in both the cases, if we taken here it is 2 pi radian, in both the cases we have taken the unit circle. So, we can say this 2 pi radian is equal to 360 degrees like here, or if we divide both sides by 2, we get pi radian equal to 180 degree. If we use approximate value of pi, that is 22 by 7 in place of pi here, we can say 1 radian, pi radian is 180 degree. So, we can say by unitary method 1 radian is equal to 180 degree upon pi, and if we replace value of pi, approximate value of pi, that is 22 by 7, then we get its value 57 degree and 16 minutes approximately. And vice versa, if we take this 360 degree equal to 2 pi radian, 180 degree equal to pi radian, and 1 degree will become pi upon 180 radians. Approximately its value after replacing pi 22 by 7, we get 0.01746 radians approximately. Now, whenever writing angles in degree or radians, we adopt few conventions, like whenever we write theta to the power, this degree, this superscript, you can see a small circle, we mean the angle whose degree measure is theta degree. And whenever we write angle beta, we mean the angle whose radian measure is beta. What I mean to say is, for degree we need to write this superscript 0, but for radians we need not to write. In some of the books you may find written like this, beta superscript c, but it is generally omitted, and need not to write even I want to write 60 degree, I need this symbol, but if I write pi by 3, I can easily omit this radian sign. This is not required every time, because whenever we write this angle in pi by 3, pi by 6 or pi by 2, this itself explains that this angle is in radians. So, we can easily omit this radian sign. It is generally omitted. Now, as I have explained in the previous slide, if we want to convert degree measure to radian measure, we need to multiply it by pi by 180, and if we need to convert radian measure to degree measure, we need to multiply 180 by pi with radian measure. Now, we will be doing some examples to convert degree to radians and radians to degree. See this example. convert 40 degree 20 minutes into radian measure. What we first need to understand is this is completely not in degrees. This 20 minutes needs to be first converted into degree, then only we will complete it into radian measure. So, how we can do that? 60 minutes make 1 degree. So, 20 minutes will make 1/3 of a degree. So, we can write 40 degree 20 minutes as 40 is to 1/3 degrees. See, as we have converted this into 40 is to 1/3 degree. As I told you, whenever we want to convert degree to radian, we need to multiply pi by 180 to radians. This pi by 180 into the given degree measure. 40 is to 1/3 is converted into 121 divided by 3 radians. Now, when we multiply it and solve it, this will give us 121 upon 540 pi radian. So, this is the answer for this question. Now, another question, this time radian to degree measure. For radian to degree measure, it is very simple. We just need to multiply given radian measures, given radians into 180 upon pi. So, see how it is solved. So, we were given 6 radians and 180 degree into 6 radians, simply multiply it and we get here 180 multiplied by 6, 1080, and replacing the value of pi 7 upon 22, solving it, it gives 343 is to 7/11 degree, but question does not end here. Since it is a proper fraction, we need to convert it into minutes. How we can convert into minutes? As you know, 1 degree is equal to 60 minutes, and here we have 7 upon 11 degrees. So, 60 into 7 upon 11, and solving this, it will give us 38 minutes. Then again 2/11 minute are left, which is again a proper fraction. We need to convert this 2/11 minutes again into seconds by this. So, for converting it to seconds, 2/11 minutes into 60, and solving this 120 upon 11, this will give us 11 seconds, and few more points will be there that we can easily ignore. That is why we are writing approximately. So, finally, we can say 6 radians is equal to 343 degree, 38 minutes and 11 seconds. So, another practical example, find the radius of circle. Here we need to find this radius of circle where central angle is 60 degree, it is given, and which intercept an arc of length 37.4 centimeter. This arc is 37.4 centimeter. This is given. Now, you will simply say it is very simple because the arc length is 37.4. Now, we need to find radius. You will say simple, we can apply this formula, theta is equal to L upon R, where arc length is given. We need to find radius and just put the value of theta given. But no, here we need to first convert this theta or angle into radians, because this formula applies to only radian measure. Remember it. So, here if we put the value of arc length, we can replace R is equal to, because we need to find R, we will take it here, and L upon theta. and theta in radians. So, 60 degree is equal to pi by 3 degree radian, we have just discussed. So, 37.4 upon pi by 3. Replacing the value of pi as 22 by 7. So, we will get 35.7. The radius is 35.7. Now, another example, the minute hand of a watch is 1.5 centimeter long. How far does it move, tips move in 40 minutes? First of all, I would like to tell you why we consider minute hand. Why not second hand? Because minute hand is longer and it swipes the whole area, not the second hand, which is smaller. So, minute hand of the watch is given to be 1.5 centimeter. How far does it move in 40 minutes? You know, in 30 minutes, you from here to here, you cover this much distance. As it is clear, this is pi angle, but 40 minutes, when you reach here, you need to find what is the angle here. Mathematically, how we can find? So, in 40 minutes, minute hand will reach here at number 8. As you can see, this covers 2/3 of the whole revolution. 2/3 of whole revolution is 2 pi. So, this makes 4 pi by 3 angle theta. Angle theta traced by minute hand is 4 pi by 3. Applying this formula, arc length is equal to radius into theta, angle subtended at the center. What we know here? Radius, because minute hand is taken as radius of the circle, which is 1.5, and theta we have just converted into radian, that is 4 pi by 3. Taking product of this radius and this angle, here we will get arc length L, 1.5 for r, 4 pi by 3 for theta, and we will get here, if you solve this, this will be 2 pi centimeters, and replacing the value of pi as 3.14, we will get 6.28 centimeter of arc length. This is the distance traced by minute hand in 40 minutes, which is 6.28 centimeters. Now, another very important example, if the arc of same length in two circles subtend an angle of 65 degree and 110 degree at the center, we need to find the ratio of their radii. Here we are given two circles. We consider this circle with radius 1, this circle with radius 2, arc lengths are same, let this is the arc length. This subtends an angle of 65 degree, let this angle be theta 1, and another angle, since arc length is same, so arc length is same, this makes an angle of 110 degree, take it as theta 2. See here, let R1 and R2 be radii of the two circles as we have taken. Theta 1 is angle 65 degree, and if we convert this into radian, this will give us 13 upon 36 pi radian, and another circle, second circle with the radius R2, where theta 2 is given to be 110 degree. If we convert it into radian by multiplying it by pi upon 180, this gives us 22 upon 36 pi radian. What we have been asked, we are asked to find ratio of their radii. If we write the formula, L is equal to R theta for these two different circles. Since arc length is same, we need not to write it separately L1 and L2, we can take them as same. This is R1, theta 1, R2 and theta 2. Glens are same. Comparing these two, we can very well write r1 theta 1 is equal to r2 theta 2. Ratio is required. So, bring this r2 here in the denominator. Take this theta 1 there, theta 2 upon theta 1. So, for finding ratio of the radii, we need to find ratio of their angles, but in inverse direction. Theta 2 first divided by theta 1, which we have already converted into radians. So, 22 by 36 pi radian in the numerator, 13 upon 36 pi in the denominator. After solving this, we get pi will cancel out. I write it here. This theta 2 up in the numerator and theta 1 in the denominator. Pi will cancel out. 36 will also cancel out. What do we get? We get 22 upon 13. So, ratio of their radii is 22 is to 13. That's all for today. So, viewers, today we learnt about to convert between radian measure and degree measure, and we did few more examples and sign convention. In our next module, we shall cover trigonometric functions, signs of trigonometric functions, domain and range of trigonometric functions. Thank you. Stay tuned. Have a good day.